Hi, and welcome to Maths Appeal. I'm Susan Okereke.
And I'm Bobby Seagull.
And I, Susan Okereke, am a maths teacher and communicator that loves teaching maths, and I want everyone to love maths.
I'm a TV presenter, author of The Life-Changing Magic of Numbers, and also a fellow maths teacher.
And as Maths Appeal, we want to welcome everybody into the world of maths. We want to demystify it, we want people not to be scared of it, and we want to show students, parents, fellow maths teachers, everyone really, that maths is for everyone.
Absolutely, because again, that word fear, when you mention maths to most people, they're like, yeah, I'm afraid of the subject. But we actually think that it can be fun, it can be enjoyable, because the world actually does revolve around numbers. So this is episode 2 of series 2 of Maths Appeal. And this season, we've got a different focus to season 1. So what is the focus, Susan?
So we are spending time and we want to kind of showcase how to problem solve and to think mathematically.
And we think that actually the best way to tackle problem solving is actually to do problem solving, because the reality is, as teachers, we know that it can be tricky to teach this topic because it's almost like a mindset, but actually the way to develop that mindset is by practicing and doing different problems.
And we also want to show that it's fun, like it's okay to make mistakes and people do things in different ways, and that's totally fine. And we wanted just to showcase the fact that people think differently and to demystify the idea that there's only one way of doing it and the answer is all that matters. And we want to sort of change that.
Definitely. But also we'd like your help, because if you think there are specific skills that you want to learn, let us know. You can tweet us at Maths Appeal if there are any subject or maths problems that you'd like us to cover.
Yeah, and every episode will feature a maths problem, which we'll work through together. And hopefully we can help you feel confident in your solution, and we'd love you to share it with us as well.
So now you should probably be quite familiar with from episode 1, a structure that we have a look at. Because we think that when you first sit down to see the problem, you're going to get these questions going through your head. Like, firstly, how do you feel when you first encounter that problem? Then secondly, you're going to have to think, does that problem actually make any sense to me? And then do I have any questions about what this specific problem is? And then moving on to what are the maths topics actually in this particular question?
Yeah, because we want to highlight the fact that math is actually quite an emotional subject. And so once you've dealt with your emotions and you're like, ready, I'm doing this, we then want you to ask the question about how to do the problem. So things like, what facts do we know from this problem? What rules, what formulas do we have to remember to do this problem? And then what facts can we derive from the problem? And once we've done that and we've done all the clues, what answers can we work out, and can we now work out this question?
Brilliant. So Susan, now that we know how to tackle a problem, we want you all to go and grab a pen, paper, phone, papyrus, whatever you write with, and we're going to get cracking into the problem right after this. So here is our problem for today's episode. So are you feeling hungry? Are you feeling peckish? Because when I am, I like to get pizza.
Yummy.
Yummy pizza, yeah. Pizza. So the problem for today is, if you're hungry and want the most amount of pizza, are you going to order a 12-inch pizza, 2 of them, or one 18-inch pizza? So the problem is you're trying to get the largest amount of pizza, and you've got 2 options. Is it 2 lots of a 12-inch pizza or one 18-inch pizza? We are going to tackle that in a moment, in a jiffy. But while you're thinking about that, we actually want to talk to you about maths confidence in adults. And Susan and I, we sort of understand that as teachers, students, they'll be listening to this podcast. The ones that enjoy maths, but also actually there'll be people that maybe are not so confident in maths, they'll be listening to us. So we want to have a little discussion about what adults can do. So Susan, we're going to talk a little bit about something called National Numeracy Day as a concept and the organisation. Susan, what exactly is National Numeracy Day all about?
I suppose starting with the charity National Numeracy, they are their aim is to improve numeracy, and that's people being able to use maths in their everyday life across the country. So that's their big aim, isn't it? Their big mission. And National Numeracy Day, they do once a year, every May, And it's to celebrate maths in the real world, but also to get people talking about it and to get people, acknowledging the fact that it can be challenging, but also it feels really great when you improve, and just it's like a celebration of how you can improve in mathematics. So that's kind of National Numeracy Day.
And that talking about it concept is so important, because people that are not confident in maths often will try to hide away from it. Like if they see an Excel spreadsheet at work, or they see a budget, or they see numbers somewhere, they'll try and shy away. So firstly, we want to say well done to you for actually listening to this podcast if maths isn't your thing. Clearly, that's a great step. So now you're listening, but the second step is to have that conversation. In fact, National Numeracy, they've started terming this as like a big number natter. So natter's it's a northern word, isn't it, Susan?
Yeah,
Natter.
to mean talk, to have a good old chat.
Yeah, so what do they mean by like having a number natter?
So I think the aim was just for them to get people to to normalise talking about numeracy and maths, with the view to acknowledging that some people like it and some people don't, but it is in everyday life. I think just to kind of reiterate the issue that in the UK, there is a problem with poor numeracy. That's like one of the reasons this charity got set up, is because over half of the adult population in the UK have the number skills and numeracy skills of less than an 11-year-old, which is terrible, and that's people who are parents, and who, are in the working environment, and they're, scared. So the whole point of the number natter is to try and normalise the idea that different people have different ideas and different kind of feelings about maths, but everyone acknowledges the fact that to be good at it and to get confident and to get better at it can really improve your life chances.
Yeah, again, so we're glad that you are listening to the podcast. We're glad that you're having a conversation about it with your friends, your peers, your family. But then you might be thinking, okay, I'm now feeling more positive about talking about numbers. I'm not as ashamed that I'm not as confident at maths as I should be. But now they want to do something about it. And this is where National Numeracy can help. They've got something called the challenge. So like, what exactly is the challenge?
It's like an online, I guess, assessment, but not in a scary way. I think it's like you can go on and do a self-assessment, and it tells you where you're like confident and not confident in maths, and then it gives you kind of self-directed learning. So where, say you're like, fractions, I've always found it difficult. They're like videos and activities you can do to kind of fill in the gaps and to get confident at it. Because the key thing is, once you acknowledge the fact you can't do something, and then you work on it and you suddenly are able to do it, doesn't it feel amazing? So it's kind of, this is an idea, the amazing resource, amazing tool that's completely free, and you can do it in your own time, at your own pace. Then the challenge is there for anyone who wants to improve in maths. So, the big point, I think both you and I, Bobby, but definitely one of the things I'm really, 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 really want to push is like, doesn't matter how bad you think you are at maths, you can get better. And what's great is National Numeracy, the challenge, is a really great way of just getting started with that. And there's loads of support if you want it. So as a charity, I'd just get in touch with them.
Oh, that's actually that. I wanted to sort of pick up on that concept of it being a skill. Because in fact, one of the National Numeracy ambassadors is a lady called Katia Jones. And if you're a Strictly fan, you'll know that she's been a former Strictly professional champion, actually. And she talks about the fact that maths and numbers shouldn't be this big, scary monster. And some people are like, oh my God, they're scared of maths. But actually, if you see maths as a skill that you got to learn, like dancing or baking or driving.
Or a language, or, anything, like riding a bike, as you say, or construction, like...
all these things.
Yeah.
And you're not born being able to ride a bike. You're not born being able to cook a pavlova cake. You're not born being able to dance the tango. You're not born being able to understand percentages.
No.
You're not. But people think, oh, only a certain kind of person can do maths. But I think as adults, if you realize it's a skill, like most things in life, if you're not good at it, fine, acknowledge it, talk about it, and then use things like the National Numeracy Challenge as a way to try to improve that skill.
And, and I think we want to just put it out there as well for people who are parents and are like nervous about maths too. This is actually a great way of being able to support your kids as well. And I think saying to them that you find it challenging, but you're also doing something about it, is an amazing thing to be showing your children. That learning is lifelong. You should all be aiming to be lifelong learners. And if maths has been something, or numeracy has been something that you found challenging for a long time, But why not try and improve that now, especially if you've got children, because they can also help you as you improve, so it should be like a team, as I say, a collaborative, community based kind of way of learning, okay, and not scary, fun.
Exactly. So we'd love to hear, again, please do share your stories about any adults that you know in your life that have taken steps to improve, because sometimes celebrating and championing these stories can show people, actually, yeah, I saw Jim from the NHS, or I saw Lisa who works in retail management, and they improve their numeracy. So the more of these stories we share actually inspires other people.
And a big thing that we think we should do is go onto the National Numeracy website, and there's loads and loads and loads of numeracy champions on there who have found math difficult, done the challenge, and now they love it. Math is now their friend. So this is like, if you wanted inspiration and you were like, I'm scared to do it, go onto the National Numeracy website, have a look and see if that will encourage you to check out the challenge.
That's brilliant. So maths is your friend. And in fact, we're going to pick up with a friend, our puzzle friend.
Should we get back into it? Should we try and solve it, shall we? If you are hungry and ordering pizza, do you go for 2 12-inch pizzas, or do you go for 1 18-inch pizza?
Yeah, so you're trying to get the one with the most pizza. So sitting down to do this problem, like, Susan, how did you first feel when you heard this problem?
So my automatic thought was, obviously it's 2. Then I thought, because I thought 2, because 12-inch is
12 times
not
2
that much less than 18. But I was like, wait a second, I need to work this out. So I was like, okay, in my mind I thought, obviously 2, because 2 is more than 1, fine. But then I thought, do you know what, let's work this out. So that was my initial thought. What about you?
So I think the first time I saw a similar type of problem, I'd seen it's one of those viral type problems.
Oh yeah.
I thought it's obviously going to be the 12-inch one, but I thought these problems often they got a little twist, a little sting. So does that problem actually make sense to you? Did you have any thoughts about the problem?
I suppose when I first saw it and when you said it, I was like, when they say 12-inch pizza, is that the diameter or the radius? I just had to confirm that.
Oh, I never thought about that. That's an excellent question.
So, and then it's the diameter, so that kind of made the difference as to kind of the way I thought about it. Yeah. But that's why I needed to kind of confirm that. And then when it came to what topics, did you have any questions when you saw it?
To be honest, I'd not thought about it. I just assumed it was the diameter rather than thinking when it could have been the radius. Actually, I never thought. I just made an assumption. Which is good to think about it.
Well, it is. Well, also, I asked you, so that I use diameter, so if it's wrong, oops. But we can do our comparison still. And so what are the math topics in this question? So the idea of the area of a circle.
Yeah.
And then just a bit of a comparison between 2 different amounts, I guess.
Exactly. So now we're going to, I guess, look at how we actually did the problem. So the questions, again, what facts do we know from the problem? What rules and formula are needed? What sort of facts can we derive in the problem itself? And could we answer it? So firstly, what do we know from the problem, Susan?
So we know the diameters of the smaller pizza, which is 12 inches, and then we know the diameter of the big pizza, which is 18 inches. So that's some facts. And we know, and also, we are presuming that they are circular as well.
Yes.
We're presuming they're circular as well. So that's kind of what we're using as our thing. And so what kind of formulas do we need to be aware of to be able to answer this?
So I think, again, if we're assuming it's circular, not those weird square pizzas, then it would involve the area of a circle, which is... what is this? I learned this method from my students. Cherry pie delicious, apple pies are too. Now people are thinking Bobby's gone mad. I actually haven't. So cherry pie delicious is CPD, which is circumference equals pi times diameter. And then apple pies are too is area equals pi r squared. So cherry pie delicious, apple pies are too. That sort of is a way of remembering circumference equals pi times diameter and area equals pi r squared. One of my students told me this.
Oh, well, if it helps remember it, I suppose I just know it now. I don't have a mnemonic for it. But for us, we need the area, which is pi times the radius r, or radius squared. And so for these, so we go through what's the next. We've got our facts. We know information. So should we do some working out? So
let's do it.
So I think I just plugged the stuff in. So the key thing was just knowing that we need the radius. So for our big pizza, the radius from a diameter of 18, that's all the way across through the centre. The radius is from the centre out to the circumference, and that's 9 inches.
Correct.
So the area for the big pizza is pi times 9 squared, which I've not changed. I've just kept it as 18 pi. So I've kept it in terms of pi to not use my calculator. Sorry, 18, sorry. 81. 9 squared is 9 times 9, which is 81 pi. Sorry, I made an error. Which happens to the best of us, guys.
Oh, that's nice. Yeah, it shows you even like, brilliant maths teachers like Susan and
Hello.
myself. Yeah. But again, there's nothing wrong with making a mistake as long as you can understand what you've done and then you can go back and correct. In fact, I think it's better to make mistakes because then your brain starts almost like working out what future mistakes you might make and try and preempt it. So
You're welcome. That's a mistake. So the big pizza area is 81 pi. And how do you get the small one?
So the small one, so again, you think about what's the radius, pi r squared. So it's 12 divided by 2, that's 6. So pi r squared is pi times 6 squared, that's 36 pi. But, don't forget there are 2 of these pizzas. So it'll be 2 times 36 pi, so it's 72 pi inches squared, as it were. So now we've got 2 areas.
And so our biggest area, so the most amount of pizza we get from the 18-inch pizza. So the one big pizza, there is more pizza surface than the 2 smaller ones, which when I first worked it out, my mind was slightly blown, I'm not going to lie to you. But it's also that's quite crazy though, isn't it?
It's one of those problems where similar versions about area, scale factors go viral. People are like, no, it's not possible. But when you sit through the maths and you do it and you're like, even now, it's like still a bit counterintuitive. I still think, the 12-inch pizza is going to be bigger, the 2 of them, but the maths just shows actually no.
Yeah. I mean, so to extend it, so always as I like to kind of throw in a bit of a curveball. So what other questions, I suppose, could you ask based on the ideas of this, I guess? Like,
Ooh, I've got a thought.
Go on.
So I think it could be, how much would you need to increase the 12-inch pizza by, diameter-wise, to make it the same?
Yeah, or to make the 2 smaller pizzas bigger than the area of the bigger one.
Yeah, or even exactly the same. Make it
Exactly
81.
the same.
So make it 40.5 pi inches squared each.
Oh, then you can compare it. Yeah.
Yeah.
Because also as well, like, would it make a difference if you threw in the price of each of the pizzas as well? Like if there was a deal on or something, have a little bit of a play with these type of things. So anyway, just thinking about ideas on how we can extend these types of questions. So if you have any ideas to build on this, get in touch at Matt Appeal on Twitter, Instagram. Fill us in with some more ideas regarding pizza, which is our favourite.
We love pizza, but one thing we love more than pizza on this podcast are facts, because facts feed the mind.
Indeed. So I've got one for you today. So it's normally Bobby's job, but occasionally I'll pop in with a factoid. And I learned something recently about the idea of so tell me again, Bobby, how do you work out the area of a circle?
Cherry pie delicious, apple pies are 2. So apple pies are 2 is, area of a circle is pi r squared.
Right. It's the wrong answer. Because, can you give me a definition of what a circle is, Bobby?
A circle is... a circle is a...
Should I give you?
It's a good question, actually. I never really think about that. Go on, it's...
So a circle, the technical definition for a circle isn't just it's a round shape. Okay, it's round. The technical definition for a circle is a locus of points equidistant from a fixed point. So a locus is just a lot of points that are the same distance away from one point in the center. Okay. So technically, a circle is empty.
Oh, because the circle is actually just all those points
around the outside. So actually, when we're trying to find the area of a circle, we're trying to find the area of the disc enclosed by the circle.
Oh, that is sneaky.
All those math textbooks that you see asking for the area of a circle are incorrect.
I dare you to try that in your GCSE exam, students.
I know.
You can say, Auntie Susan told me that circles are locus of points equidistant from a fixed point. Therefore, what you're actually trying to work out is the area of the disc. QED.
You should really get extra points for that, I'd say, but I would probably imagine you'd probably get marks taken off for being
But
a bit of
you're
a
spot
clever
on there,
coz.
actually. I never thought about that. Because the circle is a construct, but actually the area is the disc, actually, that we're talking
Yep.
about.
So it should be, how do you work out the area of a disc?
I'll never look at a circle in the same way again. So, if you want to send us maths facts like that or problems, we'd love you to get in touch with us. We're, as usual, at Maths Appeal on Twitter and Instagram.
Or you can email us, old school, at mathsappeal1, the number 1, at gmail.com.
So that's about it for this week. Again, we really appreciate you downloading this episode of Maths Appeal. And genuinely, it makes such a big difference if you can give us a 5-star rating or tell a friend, just one friend, about it. And spread the word, because we want to get more people to love maths.
Yeah, we do. You've been listening to Maths Appeal with Bobby Seagull and Susan Okereke.
And the music's been composed by Kelly Okereke. The image design is by Calix Davis. And our producer is Jenny Nelson. And we'll be back soon, and we'll see you for episode 3 for more maths problems that we're going to solve together.